All right, here we go. So this is the second section of section 6.5. We did trapezoids already. And so now we're going to do a thing called a kite. Do you guys even fly kites anymore? When we were kids, we used to fly kites all the time.
I was fun, and then I got mad at it because there was a fly.
You got mad? Yeah.
You'd be proud of me, sir. I haven't used it back in the experiment.
You used it. How did you use it?
I was making something for my brother out of wood.
And then you figured out the length of a side or something like that, or what'd you do?
I had to find out how to use.
Very good. See, there you go.
See, I had this bad experience with kites. I was flying this kite.
All right, you're just making this story up, so.
No. I was flying this kite a couple weeks ago. It was kind of like a big balloon, and like the government started shooting at it.
Yeah, that's what I thought. Pretty funny.
Oh no, that's actually he talking about the.
I heard that Chinese. I heard that balloon was the
It
size of
didn't actually happen.
What's
To him.
Chinese balloon?
To him.
That's a fast joke.
What?
I think he goes
I think it was like the size of two.
Sorry.
I'm not fat shaming. I'm obese shaming.
All right, here we go. Let's see if I can grab this and put this right there.
There's no paper in here, Jason.
Words hurt laughing at.
I don't know why this did this. Anyway, that's all right. Why? What did I just do? What's that? There we go. I don't know what's going on. Okay, let's do another one. Here we go. Let's take a look at this. You guys should be writing this stuff down.
I can't draw.
You're taking advantage of my good,
Your good drawing skills.
no, my, I don't know, what do you call it? Like, no. Anyway, I was going to say good behavior. It's not behavior. My good, I don't know, what would you call it? Like I'm just feeling,
Oh, good energy.
I guess. It's not really what I was thinking of, but that's close enough. So anyway, but if this continues, I'm not going to be in such a great mood, and I'm going to take care of all your talking and messing around. Okay? Because I can write your names down, and when I write your names down after this class, I'll put it into RenWeb and give you an ASD, and there we go. So that'd be pretty easy for me. I'm getting good at it now. I used to not rate people up at all, just because I could always take care of it. But it seems in the last 10 years, things have changed a little bit. And so now I have to rate people up all the time. Well, it's been 10 years since I taught math. This is the first, I taught a class last year. But I went a 10-year span without teaching math because I was teaching all the media stuff. And it seems like students have changed a little bit since then. So I used to be able to take care of it, but now I got to write people up all the time. You just force me to do it. So I'm getting good at it, though. I'm almost enjoying it. So you can test me if you like. All right, so here we go. We've got it drawn. So this is a kite. Now, why is it a kite? Well, I'll tell you why. There's a theorem. I'm not going to write it down, but we'll draw it on here, what the theorem says. Okay, it says a kite has exactly one pair of opposite angles that are congruent to each other. And I've actually drawn them right here. You see the angles that are equal to each other? What would they be? X and Z, right. Okay, they have exactly. Now, a parallelogram, they have opposite angles that are congruent to each other. Remember that? So there's two pairs of angles that are congruent to each other.
It's just.
All right, so a kite has exactly one pair of equal angles, opposite angles. So these two are the ones that are opposite each other right there. So that means that this angle right here is not equal to this angle right here. You with me? You can't have two pair of opposite equal angles on a kite. On a parallelogram you have it, but not on a kite. Okay? You only have one pair that are equal. So it's just this one and this one are equal. Now, here's something else about a kite. A kite has two pairs of equal sides. but the sides are not opposite each other. Remember on a parallelogram, the equal sides were opposite each other? But it's not the situation here. It's the ones that are consecutive. They have two pairs of congruent consecutive sides. Yes. Yes. Anything I put up here, you should be writing down. All right, so watch. This one and this one would be equal. Everybody watching?
Yes.
All right, they're consecutive. You see how they're next to each other? So we're not talking opposite. So like this WX and this ZY, they're opposite each other, but they'll never be equal to each other if it's a kite. All right? But there's another pair of opposite side, or I should say another pair of congruent sides that are equal, and that would be this one right there and this one right here. Do you see how they're next to each other right there? Doesn't mean that all the ones that are next to each other are equal, because look, this one and this one, they're consecutive sides. They're next to each other. Do you see it? Okay, but they're not equal, right? But you do have two pairs of congruent consecutive angles, all right? So that's really the definition, but the theorem says this. If you have a kite, then this angle and this angle are going to equal each other. Let's pretend that we didn't know that theorem. We can actually kind of look at it and prove it if we wanted to. This is not basically, it is. This is the definition of a kite, that these two sides are equal, these two sides are equal. I put that length, that connecting line between W and Y, just to show you this. What could you say about the two triangles themselves? There's one side, there's another side. What else do you see? This goes back a little while. What else do you see that might be equal to each other on here? Go ahead, Nathan. The center side, right here, right, this WY. You see it? All right, so do you remember, you probably don't remember the reason for it, but it's called the reflexive property. All right, so now, tell me something about this triangle and this triangle. By the way, why did I put 3 arcs here? Because these two triangles share that side, don't they? So this side on this triangle is exactly the same side as it is on this triangle. So it must equal itself. That's why they call it the reflexive property. You look at yourself in a mirror, you see a reflection, right? So they call it the reflexive property. So what do we have? Come on, let's think about this. This triangle and this triangle. They're congruent to each other. Why are they congruent to each other? We had a whole chapter on this. This is the easiest one of them all. Come on. There's got to be somebody in here that remembers this. Thank you. It's side, side, side. Okay, because look at this triangle here and this triangle right here. Everybody see those two triangles?
Yes, sir.
Okay, they must be congruent to each other because they both have one side congruent, they got a second side congruent, and they got a third side congruent. So these triangles must be congruent. So that means if I took those two triangles, pretend I folded them up on themselves. You follow me? So I took this one and I folded it up here. What things match up with each other? Well, the X and the Z would match up, wouldn't they? So if they're congruent triangles, the X and the Z would be exactly the same angle. You follow that? Look, if I took this triangle and I flipped it up so that this triangle sits right on top of this triangle. Everybody watching me? Mm-hmm. Okay. So what angles match up? The Z and the what? And the X. So they would match up with each other. So that's what that theorem says. The theorem says if you have a kite, which means these two sides are equal, these two sides are equal, and then you're going to have congruent triangles. If you flip this thing up, that means that the X and the Z have to be the same. What else might be the same here? I'm going to put some angle. Yeah, let's do that. Let's make it a little easier for us. We'll just put some numbers so we don't have to use all those letters, okay? So what must also be equal here? 1 and 2, right? So 1 and 2 must be equal to each other because, again, if I flipped them up, right, they're the ones that would match up with each other. They're called corresponding parts. Do you remember this? Corresponding parts of congruent triangles are congruent. We did that once, didn't we?
Yeah, you did.
Yeah. So that's why these two are equal. Tell me something about 3 and 4. They're equal to each other as well. All right. So 3 and 4 are equal to each other. 1 and 2 are equal to each other. And X and Z are equal to each other. Those 3 angles are equal angles. That's if you know it's a kite. So if you know it's a kite, you should know that all those corresponding angles, the ones that match up, if I took one and sat it right on top of the other, if I took this triangle on the bottom, flipped it so it sits right on top of this triangle right here, then these two angles would be exactly the same, these two and these two. All right? That's going to help you out because they're going to give you some numbers in here, and you're going to have to figure out what the other angles are, right? You've seen it before. We've done it 100 times. So that's what they're going to do here. Let's put one more thing in here. In fact, let's do this. Let's make this just a different color just so it stands out a little bit. We'll make that one yellow. And let's do this. Let's make another diagonal. Let's start from X and go to Z. Is that all right?
Mm-hmm.
Yeah, right there is good enough. And let's just make this a different color just to be different. We'll go to that pink color. Yeah, it's kind of hard to see, isn't it? Can you see blue any better than that? Let's see. Blue. Yeah, it's a little bit better on the screen. Okay. Now, look at this. This is not a rhombus because we've talked about this as far as a rhombus is concerned. This is not a rhombus. It's a kite. In fact, it's not even a what? Well, no, the whole thing is a kite. But this whole thing, it's not a rhombus, so it's also not a... What's the four-sided figure we do a lot with? A parallelogram. So this is not a parallelogram. Everybody understand that? So this is really different than anything that we've talked about before. Well, the trapezoid wasn't a parallelogram either. That's why it's in the same section. Trapezoid and kites. You follow me? Everything that we talked about before were all parallelograms. Rectangle was a parallelogram. A rhombus was a parallelogram. Okay, a square. All those things are parallelograms. Now we have a section with trapezoids and kites that neither one of these are parallelograms. So it's not a parallelogram, but the diagonals do something here. Now, they don't bisect each other. Well, yeah, they don't bisect each other. Look at the yellow one. Does the yellow one look like it's split in half? Come on, you didn't even look, and you didn't even think. You're just saying things. Look at it and think. Does the yellow one look like it's split in half? No, because this one right here is way shorter, isn't it, than this part right here? So, but what about the blue one, though? Yeah, the blue one, okay, right here is split in half. And we have words for these, okay? I don't use this very often, but since the book has it down there, the blue, and I'll write this in blue. So XZ. All right, so why did I put a Z? Oh, that's all right. I used different letters for this for another picture here. So so XZ, they call it the crossbar. All right, they call it the crossbar of the kite. Okay, so it's a diagonal. See how it goes from one equal angle to the other equal angle? We call that the crossbar. All right, and then here's another one. We're going to use this word a lot in probably Algebra 2. Okay, next year you'll probably see this next word. So the yellow one, which is what? WY. WY. It's called the axis of symmetry. We learned that this year, right? X and Y axis. Remember this? Remember that was the X axis, and this was the Y axis. Remember that? Okay, we did that this year too, right? But WY is the axis. Everything I write down, you can write down. You don't have to ask me. The axis of symmetry. Okay, that's what they call that one right there. Now, when those two intersect each other, take a look at it. Now, just eyeballing it, what do you think might be true about the blue one and the yellow one? They're perpendicular. Exactly right. Okay, they are perpendicular. Okay, so those two right there, I'm not going to go through and show you why they're perpendicular. Let's just know that they are. All right, so on a kite, the two diagonals are going to be perpendicular to each other. That's for every kite. Yes. Okay. All right, so the diagonals are perpendicular. Now, the crossbar one, is actually split in half. All right, there's a lot of stuff to remember on this. So you're going to have to go over it and read over your notes a bunch of times. So for instance, what if I said, let's make it blue. Oops. That's good enough. That'll work. All right, so what if I made that 5? Tell me what, I don't know what this is in the middle. Call it Q, whatever. All right, it's supposed to be a Q. So Q is in the middle. So if XQ is 5, tell me something about ZQ. It's got to be 5 as well. all right? But you know what you're going to do. Seems like I say this every day now. You know what they're going to do eventually, right? Instead of just making this 5 and asking you to find that, make it 5, what are they going to do this? They're going to say it's like x minus 2, and they're going to say this is 3x minus 5 or something like that, okay? And then what would you do to them both? You would set them equal, solve for x, blah, blah, blah. We've done that dozens and dozens of times in here, haven't we? Maybe even 100 of times. Don't worry about this. Okay? So that's what we're going to eventually do. Same thing with the angles, all right? So make sure that you know that the angles are all equal. You could even say that this angle right here, do you see that one right there? What's equal to that angle? Well, this one down here. Do you see those blue ones right there? So this little skinny one here and this little skinny one there, they're going to be equal as well if you put those diagonals in there, all right? So that's a lot of stuff that we know about a kite. So now let's do this. Let's do an example. Let's go back to white. And now let's draw another kite. All right. And tell you what, it's easier if I just start out like this. Everybody's watching, right? Just because I'm drawing another picture, does that mean you should be fooling around? Kind of looks like a kite we're used to, right? Ready to fly. When I was, and they actually, they do this in the book. They actually name it kite, K-I-T-E, and they make this an X in the middle right here. All right. So they tell you it's a kite. All right. So they say it's a kite. K-I-T-E. There's no like symbol or anything for it. Okay, but that's, I know it looks like kite, but it's the word kite and then K-I-T-E, right? K-I-T-E. That forms a kite. Okay? All right, so now they tell you a couple things. Here's what they tell you. Sometimes they'll use this phrase. You'll see this quite a bit. You'll see given. We haven't really been doing any official proofs in here. You would have seen given a long time ago, but here we go. Angle XKE. XKE is 55 degrees. For those who have their heads down, you're not gonna get this stuff. All right. And what did I can't even read my writing. What did I write down?
Jason, stop playing. Just see.
Okay, I see what they do. Okay, watch this. So K-I, guys, please. I take like 5 seconds to stop writing, and you guys go crazy again. Have a little self-respect. Goodness. Right? I'm serious. It's what it is. It's self-respect. Okay, you don't have any self-respect or respect for anybody else, your fellow students or me. Okay, just because I take 5 seconds to stop and look at my paper, then you guys go nuts. Really, it's so disrespectful, not just to me, but to yourself. Okay, it's embarrassing, to tell you the truth. 10th graders acting like that. It really is. You should be embarrassed. That's what I would say. All right, just saying. All right, here we go. So we know it's a kite. Now, right here, we didn't talk about this, but I'll show you why they did this. Okay, because it says Ki is less than Ke, so this is the shorter side. So we know, since it's a kite, what do we know? We know this side and this side are equal to each other, and we know this one right here and this one right here are equal to each other. What else do we know about this since it's a kite? I know that the diagonals do what? Form a right angle. They're perpendicular, right? So I do know that as well. I don't even know if I'm going to use that or not. I might, but I'll stick it in there because I know it's true. All right? Let's see. I think they tell you something else. Oh, they're right here. XKE. Where's X? There's XKE. It's 55 degrees. So they tell you that. So that's this angle right here. That's 55 degrees. All right? That's all the stuff they tell you. Well, they didn't actually tell you that these two sides are equal. That's something you should figure out on your own. If they tell you it's a kite, you should know that Ki and Ti are going to equal each other. that KE and TE are going to equal each other since it's a kite. Everybody good? Good with that? All right. And the reason they say that KI and KE, or KI is less than KE, is just saying that this one and this one are not going to be equal to each other because they are consecutive. They are next to each other, right? So it means that these two have to equal and these two have to equal. All right, enough of that. Let's find a bunch of stuff. They ask you to find 5 different things. All right, so find. A is angle KTE. All right, let's just start with this one. Let's find KTE. And let's do this in a different color so it stands out a little bit. Where's KTE? KTE, that's this one right here. Without doing any math whatsoever, you should be able to look at that and see what that's going to be. That's right. Remember, this triangle and this triangle are congruent to each other. So if that's 55, remember if you folded them and they sat right on top of each other, then they would be the same angles, wouldn't they? Since they're congruent. So that would be 55. Put a degree symbol there. Look, I noticed when I was grading some tests, like somebody, like, I don't know, one of the problems says find AB. And somebody put like 30 degrees. Does that make any sense at all? It doesn't make any sense because what is it asking for? The length of a line segment. And people are putting degrees here. I think they put the number correct. Okay, they did the work and they found out and they got the right number, but they put degrees on there. Okay, that's just silly. So please be mindful of that kind of stuff. There's a lot of teachers that would mark it wrong by putting degrees. All right, I'm very tempted to. TXE. Let's find TXE this time. All right, let's find where TXE is. Well, we start at T, go to X, and then go to E. So it's this angle right there where the X is. That should be pretty simple. Again, you don't even have to do any math. What's it going to be? It's 90 degrees. That's right. Yes. So it's 90 degrees. So without even looking or without even doing any math whatsoever, this angle right there is 90 degrees because they're perpendicular, right? The two diagonals are perpendicular to each other. So that's got to be 90 degrees. So far, pretty easy, right?
Yes, sir.
Yeah, it's not too hard. Then this says find angle KEX. Angle KEX. All right, so let's go back to this. And where is KEX? KEX. That's, I'll tell you what, let's go different color on this one. We'll go blue. So it's this little skinny angle right there. So we got to find that angle right there. Or this one right here. It's the same exact angle, aren't they? You see this? Those two angles are exactly the same. So it doesn't matter if you find this one or this one. But we got a little more information here because we know this is 90 degrees, but we also know this is 90 degrees. Okay? So we could just find this one. So what do? This is not just looking and writing down an answer. You got to do a little math. Yeah, it's a lot easier though. One step. One arithmetic step to find this blue angle right here. You could do it that way. I'm not saying you're wrong. Okay? You could do it that way, but there's an easier, quicker, one-step method of doing this. What would it be? That's right. Just take 90 away from it. Because remember, when I have a right triangle... No. I didn't ask. I just looked at you so you would stop talking and pay attention. So let's take a look. I've got a right triangle. If I know one of the other angles in my right triangle, all I got to do is take that away from 90, right? Because these two are complementary. They always add up to 90. So all I got to do is go, let's do it over here, 90 minus 55. And what is 90 minus 55? That's 35, okay? Now, is it degrees or not degrees? It's absolutely, because we're finding an angle, okay? It's degrees, so we write the angle. So that's what this angle is right there. That's 35 degrees. Now, knowing that, part D should be really easy then. I'll just continue D down here. So part D says angle KET. Find the angle KET. All right, let's find where it is. KET. Well, where is KET? That's this whole big angle right there. Okay? That's right. So if this is 35, what's this one, this little skinny one right next to it going to be? That's going to be 35. So what do you do with those two to find the whole big one? You add them up.
90.
I'll show the math, okay, just so you
70.
look back on it, and it will be 70, and it'll be 70 degrees. This is definitely something that I could put on a quiz or a test, all right? May not be this exact problem, but, right, you're going to have these on the homeworks too. Letter E's kind of strange. I'm not even going to worry. Don't even worry about part E. Don't worry about that. That was good enough. Okay? No, I won't put that on quiz. I don't even want to confuse you anymore. So, there we go. That's kites. Let's see. I didn't write down. What did I have you do? 1 to what? Oh, I had you do some weird stuff. 1 to 8 and something, right? So I'm gonna have to change my lesson plans just a little bit.
2, 8, and then 20, 23.
Let me look in the book. Let me look in the book to make sure that I do the right. Remember, I switched it up. Remember, I changed it a little bit from what was on the lesson plans. So, Bryce, go out in the hallway. I'm tired of you. Just stay out there the rest of the time. I can't deal with this anymore. Give me a second. So, it was section 6.5a. I'll just write this down so I can remember it and you can remember it too. So what was it, 1 through 8?
Yeah.
And then I added a little bit to it, didn't I? What was it?
20 to 23.
20 to 23? All right. Because every one of those was just trapezoids, okay?
Yeah.
Now, we're going to do 6.5b. And let me take a look at it. You did 1 through 8, so we can do 9 to 12. Okay, that's the that's a kite right there. And then we could do just 18 and 19 then. 18 and 19. All right? So after I stop recording this, we're going to go over the homework on this one right here. And this is your homework for tonight. Okay, right there. All right, so this is technically your homework for tonight, and we are going to go over this one in class right now. Everybody good?